In this video, I am discussing the problems on equivalent resistance using star delta transformation. First, let us take the equations for star to delta and delta to star transformation. When the delta values are given, when the delta values are given R12, R23 and R31. Now the star values will be R1 is equals to R12 into R31 divided by R12 plus R23 plus R31. And in the same way, R2 is equals to R12 into R23 by R12 plus R23 plus R31. And R3 is equals to R31 into R23 divided by R12 plus R23 plus R31. This is the R1, R2 and R3 values. That means star values from the given delta. Now, in the same way, the delta values from the star. Here, the delta values R12 is equals to R12 is equals to R1 plus R2 plus R1 R2 by R3. R23 is equals to R2 plus R3 plus R2 R3 by R4 R1. R31 is equals to R3 plus R1 plus R3 R1 by R2. These are the formulas from delta to star and star to delta. Now let us take one delta values and let us calculate the star equivalent, and in the same way let us take the star value and calculate the delta equivalent. Ohms, 20 ohms, 5 ohms. This is the delta which is given between A, B and C. Here, for converting the delta into star and replacing it in a circuit will be easy, because inside the delta we have to keep one common point. To the common point we have to draw the three resistors from the corners of the delta. Here this is, let us consider R1, R2, R3. So here R1 is equals to the elements which are connected to the node A, that is 20 into 5. 20 into 5 by 20 plus 20 plus 5, which is equals to 100 by 45, 2.22 ohms. And R2 is equals to 20 into 20 by 20 plus 20 plus 1, which is equals to 20 into 20, 400 by 45, which is equals to 8.88 ohms. And R3 is equals to 20 into 5 by 20 plus 20 plus 1, which is equals to 100 by 100 by 45, which is equals to 2.22 ohms. This is the star. These are the star values from delta. That is, star equivalent will be drawn like this between the same nodes. Between the same ABC nodes, the star values are drawn like this. That is 2.22 ohms, 8.88 ohms, and 2.22 ohms. Now, let us take the star values and calculate the delta values. Ten, 20, 10. 10 ohms, 20 ohms, 10 ohms. A, B, C. So these delta values will be drawn between the nodes. Here, this is the RAB, RCB, or RBC, and this is the RCA. So these are the delta values, how we are going to replace. So the RAB is equals to 10 plus 20 plus 10 into 20 by 10. That is equals to 10, 10 will get cancelled. 20 plus 20 plus 10, 50 ohms. RCB or RBC is equals to, say, 10 plus 20 plus 10 into 20 by 10, which is equals to 50 ohms. And RCA is equals to 10 plus 10 plus 10 into 10 by 20, which is equals to 100 by 25, 5 plus 10 plus 10, 25 ohms. This is the way we are going to get the delta values, and the delta can be redrawn like this. $50 ohms, 50 ohms, 25 ohms. Now let us go with the problems where we are going to have the star to delta and delta to star transformations. Now here, if you see this circuit, this is the circuit which is given. Here we cannot say that the resistors are in series or parallel. Then we have to check that whether the resistors are in delta to star transformation format. Here, if you see the circuit, here we are having how many stars and how many deltas are there, that we need to identify first. Here this is one delta, 4 ohms, 6 ohms and 8 ohms. And here also 4 ohms, 6 ohms and 8 ohms is another delta. Two deltas we are having. And how many stars are there? That is 4 ohms, 8 ohms, 6 ohms. This is one star. And this is also one star, 6 ohms, 4 ohms and 8 ohms. And here this 4 ohms and 8 ohms is also another star. So total 3 stars we are having, 2 deltas and 3 stars. So here first we need to identify which delta or which star is to be converted into star to delta or delta to star transformation to get our easy solution. So we have to check that whatever the delta or star which is connected to all the elements, that delta or star we need to choose for transformation of the star to delta or delta to star, so that our the problem solving will be easy. So here I am taking this 4 ohms, 8 ohms and 6 ohms as the delta I am considering. So here this is the R1, R2, R3. These are the resistors which are connected for star transformation. So R1 is equals to, this is delta to star transformation, that is 6 into 4 by 6 into 4 by 6 plus 4 plus 8, that is equals to 24 by 8 plus 4 12 plus 6 18, 1.33 ohms. And R2 is equals to 8 into 4 by 6 plus 4 plus 8, which is equals to 24 by, sorry, 8 fours are 32 by 18, 1.77 ohms. And R3 is equals to 6 into 8 by 6 plus 4 plus 8, which is equals to 48 by 18, 2.66 ohms. So we got the R1, R2 and R3 values. Now let us replace our circuit with these resistances. Now the circuit will become, this is between A, B, 4 ohms, 4 ohms, 8 ohms. Here it is 1.33 ohms, 1.77 ohms, which is whatever the resistance which we have calculated, that only we need to replace. Otherwise, our answer will be wrong. 2.66 ohms. Now, if you see this circuit, this 4 ohms and 2.66 ohms are in series, and 8 ohms and 1.33 ohms are in series. So here 4 ohms and 2.66 ohms are in series. So when 4 ohms and 2.66 ohms are in series, R equivalent 1 is equals to 4 plus 2.66, which is equals to 6.66 ohms. And 8 ohms and 1.33 ohms are in series. R equivalent 2 is equals to 8 plus 1.33, which is equals to 9.33 ohms. Now we got R equivalent 1 and R equivalent 2. Now let us replace the circuit with this R equivalent 1 and R equivalent 2. Four ohms, 6.66 ohms, 9.33 ohms, 1.77 ohms. Now, if you see this circuit, these two are in parallel. That parallel combination is in series with 4 ohms and 1.77 ohms. So RAB is equals to 4 plus 6.66 is in parallel with 9.33 plus 1.77, which is equals to 4 plus 6.66 into 9.33 by 6.66 plus 9.33 plus 1.77, which is equals to 9.65 ohms. This is the RAB value. This is the way we can go with the delta to star transformation problem. And by using this, we can easily calculate the equivalent resistance for typical circuit. The next, this is the circuit which is given between the terminals A and B. So here between the terminals A and B, here we are having number of stars and deltas. So here let us see how many deltas are there and how many stars are there. So here we are having, this is one delta, 6 ohms, 3 ohms and 6 ohms. And here we are having the different stars. This is 1 star, 2 ohms, 3 ohms and 6 ohms. And now 3 ohms, 4 ohms and 6 ohms as another star. And this 6 ohms, 6 ohms and 5 ohms as another star. So here before going with the transformation into delta to star or star to delta, first let us reduce the circuit components, because here we can say some of the elements are connected in series. Okay, so for that I am taking this 2 ohms, this 2 ohms and 3 ohms are connected in series, and in the same way this 4 ohms, 2 ohms and 5 ohms are connected in series. So first 2 ohms, 2 ohms, 3 ohms are connected in series. Connected in series. So R equivalent 1 is equals to R1 plus R2 plus R3. That is the series resistance formula. That is equals to 2 plus 2 plus 3, which is equals to 7 ohms. Now in the same way 4 ohms, 2 ohms and 5 ohms are connected in series. That is R equivalent 2 is equals to 4 plus 2 plus 5, which is equals to 6 plus 5, 11 ohms. Now we got the R equivalent 1 and R equivalent 2. Now let us replace with these values. Now our circuit will become this is B, this is A, 2 ohms, 3 ohms, 4, sorry, this is 11 ohms, 6 ohms, 6 ohms, 5 ohms, and here is 7 ohms. Here again we got the other stars as 3 ohms, 6 ohms, and 11 ohms. Here 3 ohms, 6 ohms, and 2 ohms. And here 5 ohms, 7 ohms, and 11 ohms. This is also a star. So we are having different combinations, but here it is better to go with either delta to star and star to delta transformation, which is connected to most of the elements. So here we can easily go with delta to star transformation, and here the delta which I am choosing is 6 ohms, 6 ohms, and 3 ohms. Now this is our delta which I am choosing. So here this is the resistance which we need to add, and after replacing that our circuit will be like this. Let us consider this is R1, R2, R3. So R1 is equals to 6 into 3 by 6 plus 6 plus 3, which is equals to 18 by 50, 1.2 ohms. And R2 is equals to same 3 into 6 by 6 plus 6 plus 3, that is equals to 18 by 15, which is 1.2 ohms. And R3 is equals to 6 into 6 by 6 plus 6 plus 3, which is equals to 36 by 15, that is 2.4 ohms. Now we got the R1, R2, and R3 values. Now let us replace our circuit with these values. This is our circuit after replacing the delta into star. So here we can see this one point between these two terminals. This is A terminal, this is B terminal. Between these two terminal, we need to calculate the equivalent resistance. So here we can see that this 1.2 ohms and 11 ohms are connected in series, and 2.4 ohms and 5 ohms are connected in series. So 1.2 ohms and 11 ohms are in series. So R equivalent 3 is equals to 11 plus 1.2, which is equals to 12.2 ohms. And R equivalent 4 is 2.4, 2.4 ohms and 5 ohms are in series. R equivalent 4 is equals to 2.4 plus 5, which is equals to 7.4 ohms. Now we got the circuit, and also this 2 ohms and 1.2 ohms also in series. 2 ohms and 1.2 ohms are in series. That is equals to R equivalent 5 is equals to 2 plus 1.2, which is equals to 3.2 ohms. Now our circuit will become this is A, this is our equivalent circuit. So here this 12.2 ohms and 7.4 ohms are connected in parallel. That combination is in series with 3.2 ohms. So R equivalent 6. Here I am doing two steps in one step, that is 3.2 plus 7.4 is in parallel with 12.2, which is equals to 3.2 plus 7.4 into 12.2 by 12.2 plus 7.4 to 7.806 ohms. Now our circuit will be this is B, A, 7 ohms and 7.806 ohms. RAB is equals to 7 into 7.806 by 7 plus 7.806, which is this is the RAB value we got for the given circuit. The next problem is here. This is the circuit which is given. Till now, whatever the problems we have discussed, we have gone with delta to star transformation. Here we are going to do with star to delta transformation. So here we are having different number of we are having two number of stars. This is 200 ohms, 500 ohms, and 1 kilo ohm is one star. And in the same way, 1.5 kilo ohms, 500 ohms, and 2.2 kilo ohms is another star. But we have to choose the star such that which is connected to most of the circuit. So I am choosing a 200 ohms, 500 ohms, and 1 kilo ohms as the star. So the delta values which I need to calculate is this is RAB, RBC, RCA. So RAB is equals to 500 plus 1000 plus 500 into 1000 by 200. This is 205, which is equals to 2500 plus 500, 3000 plus 1000, 4000, 4000 ohms. This is the RAB value. And RBC is equals to 200 plus 1000 plus 200 into 1000 by 200 into 1000 by 500, which is equals to 400 plus 200, 600 plus 1000, 600 plus 1000, 1600 ohms. Now RCA is equals to 200 plus 500 plus 200 into 500 by 1000, which is equals to here 500 into 2000. So here we'll get 100. So 100 plus 200, 300 plus 5, 800 ohms. So this is the RCA value. Now we got RAB, RBC, and RCA. Now our circuit will be 1.5 kilo ohms, 800 ohms, 2.2 kilo ohms, 4000 ohms, 1600 ohms. Now, if you see this circuit, this 1 kilo ohms and 800 ohms are in parallel, and 4000 ohms and 2.2 kilo ohms are in parallel. So RAB is equals to, so for calculating RAB, let us take these two combinations are in parallel. Now R equivalent 1 is equals to 1.5k and 800 are in parallel. That is 1500 into 800 by 1500 plus 800, which is equal to 521 ohms. And R equivalent 2 is equals to, here is 2.2k and 4k are in parallel. So R equivalent 2 is equals to 2.2 into 4 by 2.2 plus 4, which is equal to 1.41 kilo ohms. Now let us replace the circuit with these R equivalent values. Now the circuit will become 1410 ohms, 521 ohms, 1600 ohms. A, B. So here if you see this circuit, this 521 ohms and 1410 ohms are in series. That combination is in parallel with 1600 ohms. So RAB is equals to, directly I am writing 1600 ohms is in parallel with 521 plus 1410. Here 1600 is in parallel with 1931. 1931, which is equals to 1600 into 1931 by 1600 plus 1931, which is equals to 874 ohms. This is the RAB value. Now we'll go with the next problem. Here the circuit is given like this. So here we are having only one delta. The delta should be converted into star in order to get our equivalent resistance. So for star conversion, first we need to take the resistors between the three nodes of the delta, that is R1, R2, R3. So here the R1 is equals to 8 into 16 by 16 plus 8 plus 16, which is equal to 3.2 ohms. And R2 is equals to 8 into 16 by 16 plus 8 plus 16, which is equals to 3.2 ohms. Where R3 is equals to 8 into 8 by 16 plus 8 plus 16, 6 ohms. Now we got the R1, R2 and R3. Now I am going to replace the circuit with these star values. Now our circuit will become This is 1 ohm, 3.2 ohms, 3.2 ohms, 1.6 ohms, 1 ohm. This is the REAB. Here again, in some circuits we have to go with more than one transformation. Here again we are having the combination of star or delta combination. So for that, either we can go with star to delta or delta to star transformation. So here we can go with again delta to star transformation. So here is our resistors. This is R1 dash, R2 dash, R3 dash. So R1 dash is equals to 1 into 3.2 by 1 plus 3.2. R2 dash is equals to 3.2 into 1.6 by 1 plus 3.2 plus 1.6. And R3 dash is equals to 1 into 1.6 by 1 plus 3.2 plus 1.6. Now our star values are 0.55, 0.88 and 0.275 ohms. Now let us replace our circuit with these star values. Now the circuit will become here this 1 ohm and 0.275 are in series, and here also 3.2 and 0.88 are in series. So the R equivalent 1 ohm and 0.275 are in series. That is R equivalent 1 is equals to 1 plus 0.27, which is equals to 1.27 ohms, and 3.2 and 0.88 ohms are in series. That is R equivalent 2 is equals to 3.2 plus 0.88, which is equals to 4.08 ohms. So R equivalent 1 and R equivalent 2 we got. Now our circuit will become 0.55 ohms and 1.27 ohms and 4.08 ohms REAB. Now RAB is equals to 0.55 plus 1.27 into 4.08 divided by 1.27 plus 4.08, which is equal to 1.465 ohms. This is the way we have to calculate the equivalent resistance when we are having either star or deltas in the given circuit. In this session, I have discussed several problems on star to delta and delta to star transformation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.